So let's do a practice problem for linear regression. So right now I have a question. Can I predict cellular usage by poverty rates? And here's my data. I have 5 values for poverty rate and I have 5 values for cellular usage per capita. And know that 12.7 correlates to 54.67. Just because I have the data written out on horizontal versus vertical doesn't mean that they're not tied to each other. So the first thing it wants to know, we're going to write an equation to predict cellular usage by poverty rates. So A, what variable should be the independent variable? So again, independent is your X variable. And for this one, because can I predict cellular usage by poverty rates, you use your independent to predict your dependent. So my independent variable is going to be poverty rate. And that leaves my dependent variable as cellular usage. So think about that again. I have to use my independent to predict my dependent. So think about it. Independent is something I can't change. Dependent is something that you could possibly change. All right. So what is the Y-intercept? So for this, I'm going to need to put my data either in the website or in my calculator. So let's go ahead and look at that. So if I look here on the GraphPad software that I have linked in the PowerPoint, I have my data already put in, my X's and my Y's. And if I hit calculate now, it gives me everything that I need. So I'm quickly going to also do that for the calculator. So I'm going to bring up the calculator and I have my data in there and I'm going to go stats and I'm going to go over to calc. And I'm going to go down to, oops, where did it go? Oh, I'm sorry. I'm going to go over to test because I'm going to use a linreg t-test because it gives me all the information I need in one place. So I do that. Remember linreg t-test, I hit enter. L1 is my X, L2 is my Y. And again, if this doesn't look familiar, go ahead and go back to the PowerPoint. Okay, so this one is going to give me very similar to what the website does. So this is a good comparison. So the first thing it wants to know is my Y-intercept, and that is where Y crosses, the line crosses the Y-axis. So for this one, in the calculator, it's A, and here on the website, it's right here. So for this problem, the Y-intercept, we're going to round this up to 604. So I'm going to put this here, 604. Okay, and what is the slope? So if I go back to both of them, and I'm going to have them both back up, my slope is negative 42.776, or I can round that up. And the great thing here is you see it again, negative 42.78. So I'm going to put this here. So I have a negative slope, which means the line is going down. All right, what is the R value and what does it mean? So again, I'm going to bring both things back up and let's see. Okay. So the great thing is the calculator does give you the R. Unfortunately, the website doesn't, but there is a way to figure it out. So using the calculator, the R is negative 0.8364. So I'm going to round that up to negative, I'm going to put this here, negative 0.8, let's see, let's just do it as 4. Okay, so what does that mean? That means there is a negative strong correlation between cellular usage and poverty rates. Okay, so again, I said, and here I don't have it. So what you're going to do is you're going to take the square root of R squared, which is 0.66 0.6997. And if you do that, then you'll get the number, the 0.84, but then you have to give it the negative because there's a negative slope. So always remember that. Your R is going to correlate to whatever your slope is. So again, you're going to take the square root of 0.6997 to get your answer. And again, you've got to put the negative because the slope is negative. All right, the next question, what is your R-squared value? Well, we got that off here already, 0.6997. So I'm going to put this here, okay, 0.6997. And again, if I look on the calculator, there it is. All right, so what does that mean? That means that 69.97% of the variation in cellular usage, which is the Y value, can be explained by the variation, oops, it'd help if I'd spelled it right, variation in poverty rate, which is the X value, okay? So what does it mean? So what I'm saying is I can explain almost 70% of cellular usage by the poverty rates in this model. So remember, I'm just talking about this data I have here. I'm not talking about everything on a huge scale or anything else. We're just looking at the specific data points. Okay, what's the hypotheses? Okay, so for this one, the null is that rho equals 0, and the alternative is that P does not equal, does not equal 0. And I'm going to do the not equals that way. That way you don't have to go find the symbol, but it's the same thing. All right, so now I got to go find my p-value. So if I go here, I'm going to look for my p-value, which is 0.0774. And if I scroll down on my calculator, let's see, or scroll up, yep, there it is again. So I'm getting both the same thing from the website and the calculator. So my p-value is 0.0774. Okay, so what conclusion can I make? So if I'm looking at my p versus my level of significance, and we've done this a bunch in this class already. So I'm going to do 0.0774 is greater than 0.05, which means I fail to reject the null. Which means what? That means there is no significant relationship between these variables, okay? And it also means there's no significant relationships between these two variables in this sample. We could have a huge sample, and we actually do find that it's significant. So what does that mean? That means I cannot make predictions. Can you make predictions? Nope, because we're keeping the null, which means there's no correlation. I can't make predictions. It wouldn't make sense. If there's nothing in common, I can't predict if they have anything in common. So again, can I make predictions when X equals 12.6? I can't. Again, I found there was no significant correlation that could be made. And how did I do that? I did that based on this right here, okay? And this is the most important thing. While I found my slope, my R, and my R squared, and it did tell me something, I can't predict about it. So what would I do? I would either start looking at different variables that might affect cellular usage, or I might actually try to find a larger data set to see if there's a significant relationship in any of those. I hope this helped.